Hello everyone, we are from Group 7 going to present our project with a title Improvement Technique in Soils. Our group members are Muhammad MIRZA AIMAN bin Muhammad RADZI, Kamarul Azim bin Sahul Hamid, Nur Syamimi binti Hamzah, Siti Nur Awanis binti Yusuf, and Yip Chia.
So first, I would like to introduce a bit about our group project.
Soil can be defined as uncemented aggregate of mineral grains and decayed organic matter with liquid and gas in the empty spaces between solid particles. Soil also is one of the important materials used as to support the structural foundation and act as base of the building that will be constructed. Soil improvement. The purpose of soil improvement is to modify the natural properties of the soil itself or control the behavior of geotechnical features in order to improve the behavior and the performance of the project. The purpose of this study is to reduce the liquefaction hazard by avoiding large increased pore water pressure and to improve the soil condition for better use.
The soil condition is very important for design and construction of any structure. It is included roads, runways, and railway tracks. Besides, the most suitable foundation for the superstructure is also important. The foundation engineer will follow a decision-making process to form the most suitable foundation.
These are few conditions that ground or soil will be considered. Abandon the project.
This might be considered a practical solution only when another suitable site can be found and no compelling commitments required the project to remain at the location in question, or when the cost estimates are considered to be impractical.
Excavate and replace the existing poor soil.
This method was common practice for many years, but has declined in use due to cost restraints for materials and hauling, availability and cost of select materials, and environmental issues.
Redesign the project.
A common example is the use of driven piles and drill shafts to bypass soft, weak, and compressible soils by transferring substantial applied loads to a suitable bearing strata.
Modify the soil.
This is to improve its properties and behavior through the use of available ground improvement technologies.
In general, ground improvement is a process carried out to achieve improved geotechnical of a soil or earth material at the site. The process can be achieved by methods that can be considered to fall into one of three categories.
First, modification without the addition of any other material. Second, modification including adding certain materials to the soil or ground. Third, modification by providing reinforcement or inclusions into the soil or ground.
The ground improvement objectives usually are:
first, reducing compressibility to avoid settlement. Second, increasing strength to improve stability, bearing capacity, or durability. Third, reducing permeability to restrict groundwater flow. Fourth, increasing permeability to allow drainage. Fifth, mitigating the potential for earthquake-induced liquefaction.
there are three main techniques in improving the soil condition, which is mechanical techniques, chemical techniques, and polymer techniques.
Mechanical technique was the first method that has been introduced. The technique was known by mixing two types or more soils to obtain a material that achieves this specification. The soil blending may take place at the construction site, at a center plant, or at a borrowed area. For chemical techniques, ground quality is improved by adding different chemical compounds in the soil to reduce the problem. Methods that are used to chemically improve the soil such as addition of sulfates, desalination, addition of gypsum, and admixture of soil.
Ground freezing is a construction technique that freezes the moisture in the ground to provide a temporary earth support structure for excavation and groundwater control. It is also used to prevent groundwater from spreading contaminants through the soil. The process is relatively straightforward. Drilling rig inserts freezing conduits, which is called lancers. The refrigerant or coolant is piped through the conduits. A variety of refrigerant can be used. Circulating coolant typically uses brine at -25 to -30 degrees Celsius. Expandable coolant typically uses liquid nitrogen. Frozen ground initially forms cylinders around the conduits, while further freezing creates freezing zone in desired pattern. The benefits of ground freezing is it is an engineered structure, it is cost efficient, it eliminates mechanical dewatering, effective in all soil types. Shoring completely formed before excavation begins, flexible and adaptable, and eco-friendly. The drawbacks of this system: it takes long freezing time, usually 6 to 12 weeks, which does not include installation time beforehand. Next, the refrigeration equipment space needed, its high energy cost, and lastly, the hazardous chemicals in refrigerants and coolants. A little basic implementation for the system, which is very simple. Rods injected into soil concerned and pumped with either calcium chloride brine or liquid nitrogen. Calcium chloride is cheaper of the method, with a temperature of -25.
In admixture treatments, ground quality is improved by adding different chemical compounds into the soil to reduce the problem, thus enhance the properties and behavior of the soil. Admixture soil improvement is widely used for site and roadway rehabilitation as well as new construction projects. Admixture soil improvement can greatly beneficial in drying up wet soil, improving strength, including solidification of waste for disposal assistance, providing volume stability, reducing swell, controlling shrinkage, improve working platform and workability of soils, reduce thickness of roadway layers, and the last one is slope stabilization. For our case study, we use fly ash for the admixture. Pulverized fly ash is similar to granulated blast furnace slag. PFA is a chemical additive consisting mainly of silicon and aluminum compounds. It's a byproduct of the combustion of coal. Fly ash can be used solely or can be mixed with lime and water to stabilize granular materials with few fines, producing a hard cement-like mass. The corrosive strength of fly ash treated soils is dependent on 4 things. Number 1 is in-place soil properties. The plasticity of soils treated with Class C or other high calcium fly ash is influenced by the type of clay minerals present in the soil and their absorber water. Soils containing more than 10% sulfates have been prone to swell excessively in some applications. Also, organic soils are difficult to stabilize using fly ash. Number 2 is delay time. Delay time is the elapsed time measured between when the fly ash first comes into the contact with water and final compaction of the soil, fly ash and water mixture. Compressive strength is highly dependent upon delay time. Both densities and strength are reduced with increasing delay to final compaction. Number 3 is moisture content at time of compaction. The water content of the fly ash stabilized soil mixture affects the strength. The maximum strength realized in soil fly ash mixtures generally occurs at moisture contents below optimum moisture content for density. Number 4 is fly ash addition ratio. Typical fly ash addition rates are 8% to 16% based on dry weight of the soil. The addition rate depends on the nature of the soil, the characteristic of the fly ash, and the strength desired. The addition rate must be determined by laboratory mixed design testing. In general, the higher the addition rate, the higher the realized compressive strength.
Soil improvement processes are usually classified as application, probably mechanical or chemical technique. Soil improvement techniques are techniques that are utilized to change the ground properties to achieve favorable ground conditions for a specific purpose. For example, densification of soil, accelerating the consolidation, usage of admixture, and others. Mechanical techniques are the oldest techniques that are utilized to stabilize the soil layer. I would like to present about ground freezing. For ground freezing, it is an improvement method in which refrigeration are used to freeze the water molecule in the soil. There are 2 different ground freezing technologies, which are liquid nitrogen method and brine freezing method. Liquid nitrogen method is obtained by air distillation and it is transported by truck to the site in special tank, where it is kept at a temperature of -196 degrees Celsius and at a pressure not exceeding 2 to 3. Usually, the liquid nitrogen is stored on site in double-wall storage tank. The liquid nitrogen allows quick formation of the frozen structure in only 5 to 10 days, depending on soil condition, groundwater temperature, and the distance between pipes. For brine freezing method, inside dedicated freeze unit, the brine is cooled to a predefined temperature and afterward is pumped through the freezing pipe in a closed circuit and back to the chiller. The primary cooling agent, usually ammonia, circulates inside the freezing plant. The brine is used as a cooling agent that circulates through the freezing pipes. By changing the salt concentration in the solution, different melting point can be achieved. A basic requirement for brine freezing is an absolutely tight circuit.
Application for chemical techniques. In the burning of coal to produce electrical power, fly ash is produced. The fly ash is produced dry within the precipitators of the power station, and water is conventionally added to produce an aqueous slurry for disposal by pumping to an ash dam. The fly ash produced by black coal-fired power stations is predominantly cementitious ash. By Kristen, 1994. The fly ash produced by brown coal-fired power stations is highly variable. Brown coal-derived fly ash is typically dominated by silt and clay-sized particles. The disposal of thickness phase fly ash is increasingly common to reduce the storage volume and improve the dewatering, density, and shear strength of the fly ash. At the point when the fly ash is added to the soil, it increases the bearing property and strength of the soil and make it stabilize.
In our case study, there are two techniques that we propose, which is mechanical technique and chemical technique. In civil engineering studies, soil condition can affect the stability of a structure. Therefore, soil improvement is important to improve the soil structure. The improvement in soil structure also can improve the engineering performance in strength, reduce the compressibility, reduce permeability, and also groundwater condition. That's all from my group, and thank you for listening.